In this video, we're going to talk about properties of matter. Properties of matter are really descriptors of how they interact with the world. And there's a couple different categories that we're going to use to describe them. We're going to use extensive properties and intensive properties. Extensive properties depend on the amount of the substance present, and intensive properties don't. Another category would be physical or chemical properties. Physical properties can be observed without changing what the substance is or changing the chemical identity, while a chemical property cannot be observed without changing the actual structure of the compound. So extensive properties would include things like mass and volume, because the mass of a material you have is going to depend on how much you have, as well with the volume, because that's how much space it takes up. That depends on how much you have. Things that would be examples of intensive properties would include density, which you might think would be depending on the amount, because density is equal to the mass of something over the volume. To extensive properties, but because it doesn't matter how much styrofoam you have, it's still going to float on water. That is an intensive property. It doesn't depend on how much you actually have. Specific heat we'll get into a little bit more later in the year, but specific heat basically has to do with how well something will absorb or distribute heat. Color, my shirt is blue, whether it's the whole thing or I just cut off a little piece. Opacity, how well you can see through a material. Flammability, corrosiveness, reactivity, those all don't depend on how much of the material you have for that property. Physical properties, again, you don't need to change the identity of the substance to observe it. Examples would be boiling point, freezing point, melting point, any change of state, because you're not actually changing it into something else. For example, if you freeze water, it's still H2O. If you boil water, it's still H2O. There was no change to the identity. Even though its other properties might change, it's still the same compound. You can observe how dense something is without destroying it. Color, opacity, the odor, the specific heat, viscosity, and solubility. Those all don't require a destruction of the compound to be observed. Chemical properties that you could observe would include reactivity, corrosiveness, and flammability. Those are the three main ones, because anytime you react something, it's forming a new substance. If something corrodes, it's now forming something new, like pure iron can rust into iron oxide. And then flammability, if you burn something, it's obviously not the same compound anymore. So real quickly, just to go over the states of matter, because we're talking about physical and chemical changes like we did in the last video. Solid is a state where the material is closely packed. When it becomes a liquid, it's absorbed some energy. Molecules are moving a little bit faster. They're making new neighbors, sliding past each other. That's the difference between a solid and a liquid. Both of them take up approximately the same volume for the same amount of material. However, when you talk about the gas phase, the molecules are just more spread out, moving around way faster, more freely. There is one other state that we don't usually talk about in this course, and that would be the plasma state, which really only happens at really high temperatures where there's enough energy that it essentially rips the atoms apart into the nuclei and the